Okay, welcome back. Let's start this lesson with a warm-up, a little review of solving inequalities that involve multiplication and division. So go ahead and pause the video and work these problems out. Okay, let's see how we did here. So the first one, you should get x greater than -3, and the graph will look like this with an open circle shaded to the right. And in number 2, the answer would be m is greater than -8 with a open circle at -8 and again graphed to the right. So in this lesson, we'll start talking about solving multi-step inequalities, very similar to the skills we use for solving multi-step equations. And that'll be our objective, to solve multi-step inequalities. So we'll start here. Inequalities containing more than one operation. Okay, so they're going to require more than one step to solve. Just like we did with equations, we'll do the same thing and we'll undo those operations to get to a solution for the unknown amount. So let's just start with an example. There's no new skills here. We want to find the solutions to this inequality, and then we'll check those solutions. So our first step here is going to be to subtract the 6 from both sides. And as you can see, the reason for that is we have this constant here that we want to get rid of. And when I say get rid of, I want it to go to 0, so it's no longer on the left-hand side. When we do that, we'll end up with a one-step equation, a one-step multiplication equation. And to simplify that, or to solve it further, we need to divide, right? Divide by 3, which is the opposite of what's happening currently. Okay, so when I divide both sides by 3, we find out that t is greater than 3. And notice I'm dividing by a positive number, so my inequality does not change. It stays the same direction. Okay, let's do one more. Here's one where we're involving more than one step, so we'll solve this inequality much like we did the last example. Okay, so go ahead and do your work for this problem. And you should get a solution that says b is greater than 8. So if I go to graph this, I'll put an open circle at 8, and I'll graph it to the right. And again, it makes it easy when I have my variable on the left. Okay, so there's a couple of examples so far. I'm going to let you work this one on your own. Go ahead and pause the video, work this out, and graph it on your note package. Okay, let's see how we did here. So you should get an answer that is y is less than or equal to -7. Now I want you to notice something. Notice how my inequality is not in the same direction when I finish. And the reason for that is I'll end up dividing by this -3, which means I have to flip the inequality around. Okay, and I've kind of put that. Notice that we had to divide by a negative number, which requires us to flip our inequality symbol. And when I'll go ahead and graph this, I'm going to put a closed dot at -7, and I'll graph it to the left, which is the direction of my arrow, or the inequality either way. So let's look at another example here where we're having to write and solve an inequality, a multi-step inequality. So what's going on here? Well, we have a fence for a rectangular rose garden or rose bed that is adjacent to a deck. We know the length of the deck is 14 feet, and we have no more, okay, or at most means the same thing, 44 feet of fence. Okay, that's the most we have. So we want to find out what are the possible widths of the rose bed. All right, so I'm going to underline some things. This looks like it's important information, as is rectangular, and the word at most, and 44 feet, okay, a fence. So let's see if I can set something up. one of the things I'm going to have to do is figure out what formula I need to determine the amount of fencing. So that formula is probably going to be perimeter, right? Because the fence goes around the outside. And one thing you may want to do is draw yourself a little image of this rose bed, okay? Now we know the length of the deck is 14 feet, so I'm going to put 14 here. And that's just a placeholder, okay? 14 feet. And I don't know the width, but I know the perimeter, right? The perimeter, the most fence I have is 44 feet. Okay, I can't do any more than that. So I'm just going to put this in here, 44 feet. Okay, and I'm not going to put equals or anything. I just want you to make note that I have 44 feet of fence. Okay, but I can substitute values in, and I can use this equation or this formula and modify it a little bit to make it an inequality. So watch how I do this. Okay, so I'm going to substitute in the length, right, of the bed, okay, of the rose bed, right, which is along the deck of 14 feet. Okay, so 14 feet goes in for the length, okay, which I've done here. We don't know the width, and we know that this calculation, right, this expression has to be less than or equal to 44 feet because I don't have any more fence. So my perimeter can't be larger than that. So you'll notice I've also changed my equal sign in my formula to an inequality now, okay, which is less than or equal to 44 feet. So once I get to this point, now it's just a matter of solving this inequality, okay? But I'll start by simplifying this part here. So 2 times 14 gives me 28, and then we'll solve the rest of the inequality. And we find out that our width has to be less than or equal to 8 in order to have enough fencing for the perimeter. Okay, so we need to solve this new one in example 3 where we're using the distributive property, okay, which will be the first thing we do. Is we want to distribute, right? We want to distribute this number out in front. We want to simplify on one side of the equal sign, one side of the inequality sign if we can. Okay, so we'll start here with the distributive property, and I'm going to write it down here. So 2 times t is 2t, and then 2 times a negative 1 is a negative 2, plus 3t, and that's still got to be less than 2. I can combine these terms into 5t minus 2, which is still less than 2. Here I'll add the 2 to both sides. Okay, make sure I'm doing this right. And we get that 5t is less than 4. So now I'm going to divide it by 5, divide by 5. And I find out that t needs to be less than 4/5. So which one of these answers should I select? I'm looking for something less than 4/5. Well, this is less than 1 already. So I think my answer is going to have to be A. Let's find out. Yeah. And so A is my correct answer, right? It is less than 4/5. Now, I'll have a lot of students get a problem like this wrong because they're going to see, oh, t less than 4/5 and look for that answer here, okay? Make sure you're looking at what it's telling you. The solution has to be less than 4/5, not equal to, but less than. Okay, this one we have the variable on both sides. So let's work through this example as well together. So if I want to find the solutions to this, I like I've told you before, I like to move my variable term first, and I also want to find the one with the smallest coefficient. And here it's 4. So since it's being added, right, with a 2 to get rid of it, right, to make this go to 0, I'm going to subtract it. And I'll do the math here first, which 4n minus 4n is 0. And what I end up with is 2 is less than 3n minus 13. And now I'll move my constant term, right, this here, and I need to move it to the other side, so I need to get this to go to 0. And to do that, I'll add 13 to both sides, which results in a one-step inequality, which can be solved by dividing by 3. And I get an answer here of 5 is less than n, but I don't like, right? I don't like having my variable on the right, so I'm just going to flip it around. And I have n is greater than 5. All right. Let's let you do one on your own. Okay, so go ahead and pause the video, and I'll be back with you in a second to look over our solution. Okay, let's see how you did here. So I'm sure you all showed your work, which is great. You should get a solution that says b is greater than 3. Okay. Oh, yes. Okay, so these are important. Also, these are inequalities that have special solutions. Okay, they're not like some of the other ones we've seen, and you'll understand why as we go through this. So I'm going to quickly go through how to solve this, which here we're going to start with the distributive property. Okay, and when I do that, I end up with this simplified expression on the right. If I continue my work to try and solve, I like to get the variable terms together, so I'm going to do that next. And what you notice here is, once that happens, right, the 6 n's go away on both sides, and I'm left with this, that 14 is less than or equal to 14. Well, is that true? And so when I think about it in my mind, well, sure, 14 could be equal to 14. So what we call that is we say that since the inequality is always going to be true, the solutions for that inequality are all real numbers. It's everything, okay? So anything I give you would be correct. So that's one special solution. Let's try another one. Okay, now I know on this one I'm going to have to combine like terms first to simplify one side. So I'll go ahead and do that. I'll put them together in the same bucket, and I end up with 4p. So 9p and a minus 5p, we get 4p. And when I go to solve that by removing the 4p from one side, I get this one, this solution. 3 is greater than 6. So I've got to ask myself, is that possible? And no, it's not. 3 can never be larger than 6. So what we say for that is that it has no solution. Okay? So that's a couple of special solutions to it. And that pretty much ends our lesson on solving multi-step inequalities. So good work. We'll have some practice on this tomorrow in class.